Hello and welcome everybody. This is webinar 4 in our Soil Food Web Webinars Experience series, Restoring Soil Health with Fungi and Permacultural Principles. So as we're waiting for people to join, if you could, there's a chat button at the very bottom of your screen. If you could go ahead and open up your chat window and tell us where you're coming from. We always like to see what kind of international audience do we have. Greece is the first one to check in, and Canada, there you go. Awesome. Now we got some Texas and we got Jackson showing up all over the place. There we go. Good deal. All right, folks. Well, let's go ahead and get started. We got some housekeeping that we need to get through. So talking about the Restoring Soil Health webinar series, we had webinar 1, which was soil health, fungi, and the soil food web. Then we had webinar 2, which was applying permaculture and agroecology principles. And then webinar 3, meet the soil regen pros. And by the way, all of these, if you missed them or you want to be able to rewatch them, they're all available for you to go back and replay them to your heart's content. And then we have webinar 4 today. So this will be the last in this particular webinar series. All right, some housekeeping here. So all of the participants will be in muted mode during the duration of the webinar. It just helps us keep any kind of audio issues, and just the panelists will be off of mute. And 2 buttons we just got to familiarize ourselves with. Down at the very bottom of your screen on the Zoom, there's going to be a Q&A button. And if you want to have, we're going to have a Q&A session at the end of this webinar. So if you want to be able to ask the panelists any kind of questions, and really today's kind of soup du jour. So whatever questions you have, we'll be pulling those in. Please go ahead and make sure you put it in the Q&A section. And then we also have the chat button, which most of you have already familiarized yourself with because you told us where you came from. And this is really going to be for chatting during the webinar. And we usually get pretty lively discussions that are happening during the webinar itself. Other than that, please enjoy. And just one last thing, if you do put a question in the chat, it could likely be missed from us, from the panelists being able to see it. So if you definitely want to have a question put in front of the panelists, go ahead and make sure you put it in the Q&A section. All right. So let's talk about today's topics. We're going to have introductions 5 minutes, pretty quick, and then we're going to talk about the soil food web experience. So this is going to be what it is to be, a soil food web consultant, and also just not even just a consultant, just somebody who applies these practices. And it could just be for your own individual use, or it could be something that you want to do career-wise. It really kind of fits the gambit. And then we're going to talk about our June offer, and then we'll have a Q&A session about 25 minutes worth. Total time today's webinar is about 1 hour. If we get a lot of questions, we might push it for an extra 15. So we'll just kind of see how the questions are flowing in. All right, let's meet our panelists. So Dr. Adam Cobb, please introduce yourself.
Thanks, Brian. Yep, we're here having fun on a Sunday afternoon. Well, almost afternoon here in Boise, Idaho, where I'm at. And some of you may know me from previous webinars. There was one of the webinars in this series where I got to talk about fungi nerd topics. And just in general, I'm helping to communicate across everything at the school, the coherence of our message, especially our technical understanding of these amazing relationships between plants and microorganisms. And then I should also just say here at the top, I'm about 97% here and 3% still in bed because it seems like I've caught a little bit of a cold, but I am going to do my best to rally for today's event.
Right on. Way to stick with us there, Adam. And then Loida, I think might be having some connectivity issues, so we'll see if she's able to join us or not. She does a lot of things for the school. She's the consultant training program instructor trainer. She does a lot of the workshop leads. She owns her own consultancy business. She's definitely very well respected in this community. So hopefully we'll be able to get Loida to join. And then myself, I'm Brian Bagg. I'm a soil food web consultant. I have a couple businesses, one that my wife and I created called Sprouting Soils, and then another business that I created with Keish and Casey Ernst from Catalyst Bioamendments called Soil Matters, which we do more large-scale kind of projects. Okay, all right. Let's go ahead and Adam, take it away.
All right, Brian, thank you very much. Um, so one of the things that we wanted to do with today's webinar is just briefly go over, sort of the purpose and the strategies around the school and why participation in our learning community um, is is worthwhile for the individuals in this room and people you may know. And honestly, from my perspective, we need everyone to have more biological and ecological literacy. And so there's a huge part of this where we just need to get this message out into society in any way possible. But we're also looking for outcomes. And so we want to empower individuals and organizations to regenerate the soils in their communities. Um, Recently, on one of the big regenerative ag sort of social groups that I follow, a discussion went on about like what is regenerative, and some people define that as well, regenerative agriculture doesn't do XYZ, doesn't do these things like use herbicides, for example, in some people's opinions. And other people say regenerative agriculture focuses on these principles, things that we actually have to have in our systems. And I like that positive way of looking at it. There are principles of regenerative agriculture that I love to talk about. At the end of the day, though, if I was going to boil this down, and the thing that I feel that we're really teaching people to do here is to work with the plants and microorganisms as a kind of a steward of a process that is natural and emergent, where when we put the plants and microorganisms back together, it's what I called in the first webinar the holobiont, the whole community organism, that they will accumulate organic matter in our soils, and they will make the soils have a habitat that's more conducive to the health and well-being of all the organisms there. And a lot of times we just have to take our foot off of the scale, pushing in the opposite direction, right? Where our systems, globally in food production, in agricultural production, are actually quite degenerative, right? We're pulling more out of the land and out of the soil each year than we're putting back. And the number one way to look at that, in my opinion, is what's happening with the organic matter in the system. Are you leaving that carbon residue behind? Are you facilitating the fungi and other organisms that can lock up that carbon for longer so that it starts there? It's like a bank account that goes up and up and up and up and up. And to me, that's regenerative. Whatever you do, if that outcome is there, if the plants and the microbes together are building up your organic matter, then you have it. And that's what we teach here at the school.
Very
Do
well
you have
said.
something to add, Brian?
No, I mean, I think you hit it right on the nose. And I think, this question of what is regenerative agriculture, um, is not necessarily a bad thing. It's evolving and there's more people that are coming on board with different ideas and thoughts and practices. And I think being a community that's accepting those things and then, be able to share those best practices and knowledge, that's really to me where the regenerative agricultural space is kind of moving towards. And I think that's a great thing. So yeah, no, fantastic, Adam. All right.
So this is all based on, I would say, a passion or a dream or a vision among those affiliated with the school. We see these two paths diverging over the next 30 years. On one pathway, we sort of continue as a species with these destructive practices that lead to a loss of wildlife and plant cover and rivers and streams in our landscapes. We live in a hotter and drier and dustier world. That's one possibility for humanity, and it's really going to challenge our society if we go down that strategic pathway. There's another one where we have to evolve as a species. We have to wake up and change our mindsets and relate differently to the rest of life on Earth. And so we believe that soil life is so foundational. And it's really the power is in the connection between the plants and the microbes, right? Especially in the plant root systems, in the above ground surfaces, even internally right? We have had people like James White to speak on here about endophytes and other organisms that help the plant thrive. And when you do that, when you have that, there is an emergent property in terrestrial ecosystems where the conditions sort of improve year over year, and the target gets easier to hit with any kind of land management. And it's our dream to give people the tools and capacities to facilitate that outcome, work with the land and the soil and the biological community instead of doing things that are destructive.
Yeah, well said.
So I just want to mention about our team because we have instructors, we have support staff like myself here at the school, and we're all focused on um, building the human capital, right? So that there are more people who have put on a different set of glasses and they see land and soil management as a matter of ecology and biology instead of reaching for a chemical solution to every problem, right? The thing that I would say about what we're currently engaged with is a sort of similar to a lot of medical science, shifting from a fight symptoms mentality to a holistic health mentality, to creating systems working with the life in those systems, so that the problems are not just, it's not like playing whack-a-mole with the problems all the time.
Yeah, and I think it takes a you know, a team of people to really kind of push that education, that knowledge through. I mean, there's a lot of science that's evolving. There's a lot of science that's already out there, and being able um, to distill it down so that people can internalize that and to be able to define practices and something that allows them to translate that knowledge into, hey, there's something practical I can do. It actually does take quite a few people to kind of pull all that together, and that's something that's always impressed me about the school, was that kind of mission vision to be able to do that. All right.
Okay, and then the last thing I'll mention here is about community. So what I get really excited by in my role, where I get to have conversations across our like student body as well as with external partners and people just in this space, um, is when we start making network connections, right? When we start saying there's this individual in Zambia, there's this individual in Zambia, what if they knew about each other? What could happen there? And really nobody could predict the outcome of that ripple in the pond, right? So we are trying to create opportunities, yes, for the individual to upgrade their capacity, but also for them to see they're part of a global movement. They're part of something bigger, and that this idea is emerging everywhere. So it's been about 15 years since I decided to become a soil nut. And what I have seen is the rest of humanity waking up to the importance of soils, to the absolutely essential nature of having living soils out there, in order to feed ourselves, in order to live the lives that we are accustomed to. And there is going to be creative solutions that just come from people meeting each other and sharing ideas. This is one of the places we're trying to facilitate that.
Yeah, community, to me, this is also, I think, one of the most important aspects about the regenerative agriculture kind of movement that's out there. Um, you know, when I got into the business of doing this work, I felt at first kind of overwhelmed and alone, because there's a massive amount of information and just a juggernaut of the agro chemical kind of growing system that says this is the way you have to do it, and then you're coming with a voice that's different. And it's hard sometimes to kind of feel like you're the lone person pushing against this massive juggernaut that's out there. And community is a way, I think, to be able to help bolster yourself as far as saying, hey, look, there are other people who believe in the same things I believe. They're still trying to do the work that I'm trying to do, and I don't feel alone. And then I have the ability to discuss those things with them. Like, hey, you know what, I was with a client, or I was talking to this farmer, and their agronomist, basically threw all these things at me. And here's how I try to counter. Do you guys have any other opinions? And definitely community helps you be able to kind of tackle some of those things. And I also find that community is another way that it helps us also be able to push the message farther and louder, and really be able to get more mind share around what we're actually trying to do. The whole aspect of me, talking about feeling lonely when I first started in this, I quickly realized that there were other people that were living around me that were really starting to understand, or dabbling in the realm of soil biology, or were students in the school, or becoming consultants kind of thing. And we all agreed to reach out, and we created what we called the Sierra Soil Biology Association. And there was about, I think by the time we got our max roster, is about 13 of us that lived probably within about a 50-mile radius, and we meet once per month. And it was social. We would bring food and have potlucks, that kind of thing. But we'd also share compost, bringing samples of compost so we can share it with each other. We talked about what were kind of events that we could do. There was a farm conference, and say, hey, look, we're going to try to put a table or booth together, and so that we can be able to just talk to more people about what we're doing. And having that community was huge. Now, since then, I've moved away, and other people have moved away, and the Sierra Soil Biology Association no longer exists. But I don't look at it as a failure. I look at it as that was a moment in time. It was really needed and important for all of us to kind of get together as a group. And I still am in contact with all the people that were in the Sierra Soil Biology Association. So it's not like it went away. We're just no longer active. But as we kind of moved ourselves around, I'm sure we'll build up other community kind of groups. So I really encourage people to go out there and try to find other like-minded folks and do something in that sense. All right, Adam, anything else you want to add about community? All right.
I will say a note here about our courses. So one of our newest courses is called the Soil Food Web Essentials, and it is a much shorter and less expensive course that I was able to participate in. And it would give this overview again of what's offered in what we call the foundation courses and in our advanced programs, which is to build your base of an awareness of how the soil ecosystem functions, of that biological and ecological style of management, as well as specific tools such as microscopy and aerobic composting that can facilitate overall like a transition or a shift. So if the area you're working in has been cleared and used in like any kind of chemical style of agriculture or gardening before, there may be deficiencies biologically. There may be organisms that are dormant or have become very rare in that system that are critically important for the function. So sometimes people, they start to push that boulder up the hill and make the transition on some land. They hit a snag. Maybe they, as they're moving along, it's just tricky one year. They happen to hit a year that's pretty dry or something, right? And then they say, okay, it doesn't work. They give up, and then the soil, the boulder rolls back down the hill, and the soil is in that degraded state again. In fact, we might call it dirt. And so what we're trying to do is offer the shift in mindset, the tools, the support, so that you can effectively push that boulder over that first hill and see, okay, my soil has regenerated. I've got life in there again. I have these key functions. It holds more water. It makes the plants more efficiently nourished so that they're stronger and healthier. They can resist disease and pests. I can take care of my microorganisms so that they take care of me, right? And this is the theme around everything that we teach. What we have our courses designed to take people from essentially no knowledge beyond maybe a basic biology course all the way up to where they can put on those glasses and see the system with that new set of eyes, that new perspective about the foundational, essential nature of the plants and the microorganisms.
Yeah, for me, it's funny. I am a person that is on the never-ending search of knowledge, right? I always feel like I will never be complete in the sense of trying to better educate myself, better understand things. And when I first started in this realm, I started by reading a number of books that were out there. Really for me, I first started in permaculture. That's kind of where I really kind of dug my roots into. So Toby Hemingway's book, Guy's Garden, was essential, and looking at just the whole permaculture design course principles and all that kind of stuff. And then I read a book from Jeff Lowenfels called Teaming with Microbes, which was specifically looking and talking about soil biology. And Elaine writes the forward. And I know probably a number of you have been on webinars with me, and I've described this process, but for me, it was a very aha moment, reading Elaine's forward in that book. But the courses really had helped me kind of set that foundational knowledge that I needed, so that when I went out and was doing additional education, I felt like had some foundation or bedrock to be able to kind of buffer myself against. And I'll tell you, it's daunting when going through and looking at scientific papers and journals. There's language in there that you may not be familiar to, and some concepts. So having some of that foundation helped me, but still in the same aspect, you got to go out there and use some kind of search engine to say, what's that word really mean? What's that word really mean? And that type of thing. But I felt at least that I was armed well enough to be able to go out there and do that kind of additional research. And so the foundational part of it to me was really, really key.
And Brian, I have to add one thing here because sometimes people are pretty amazed that they can get directly to me and ask a question. And it's like the best part of every week. If I can help someone level up their way of seeing the soil system, or, I used to get primarily questions about mycorrhizal fungi since that's my expertise.
Right.
And now I get way more, I'm not going to provide a lot of free consulting to people, but I'm happy to help them put the pieces together. And we can do that in a Zoom session. We can do that via email. The main way to get a hold of me or any other staff member here, if you're interested in the courses, is to email that info@soilfoodweb.com.
Yeah, good point. Okay.
I think I covered this previously, but this was just a slide to summarize again that there's three main strategic ways that we're trying to help people have more tools to reach for, right? Uh, so often, if you go to the university system, I was part of academia for 10 years, so I've seen this over and over. They're reaching for tools from the agrochemical toolkit. And there's a lot of reasons historically and culturally, socially, why that has happened in academia. And we're essentially saying that agrochemical approach where there's these expensive external inputs, especially fertilizers and herbicides, um, that kind of were typical of the green, what we call the green revolution, that was actually a pathway that won't take us the long haul as humans, right? We were again treating symptoms, or we were so worried about having enough calories that we had to up our production as a species substantially. And now we're coming to realize these negative unintended consequences to all that chemical use, consequences for our health, for the health of our rivers and streams, for the health of our fisheries. It's all connected, right? Through the Earth system. And so what we have found is that time and time again, people need to use a microscope to see what organisms are in their compost and in their soils. They need to recognize if key functional groups are missing. So like this is a nematode, in this picture, and they're very important to nutrient cycling. And if you don't see a diverse and abundant nematode population when you sample your soil system, then you need to get them back. You need to create you need to set the stage so that they can succeed. And maybe you even need to go find a healthy population of them in your local area and find a way to get them deployed into the soil system that you have. And we do that through not only microscopy, because that's the measurement tool, but also by teaching people how to make what I call effective bioamendments. This is not a bag of compost you would buy at a big store that's been sitting in the sun and really doesn't have anything alive in it except maybe some bacteria. This is a carefully orchestrated environment. And I still have a compost pile that's maturing from the winter. So I'm watching the way that that compost changes over time, and it becomes a really amazing inoculum to bring back that biological community. And then around all of these things, the measurements and the techniques to get the organisms back into the soil, we support the system as humans by understanding holistically what I would call agroecology, the relationships that we can see in natural systems and imitate or emulate or establish in agricultural systems. And there are unique challenges in agriculture. The systems are different from natural systems, but many of the principles are the same. Many of the relationships are the same. And by focusing on what people have found to be practical and effective out there in land management, we can reduce the pressure from things like pests and diseases by making sure that our mutualistic organisms, the things that support plant health, are there abundantly and are again in that setting or in those conditions where they will thrive.
Great. I have nothing to add there, Adam. Great. So let's talk a little bit about the kind of career paths. And Adam did a great job of kind of explaining just the soil food web courses, right? So there's this the main track, which is just here we're going to educate you about the science behind and some of the practical ways that we then take that science and then are able to treat our plants and inoculate the soil and so forth. And that for a lot of people, that's exactly what they wanted. They just want to be able to have that education so they can apply it to their own environments or just become knowledgeable in that space. Then there is really the other kind of set of folks that are saying, hey, how am I going to work this into a career path? How am I going to actually do this kind of work? And it really kind of falls into two camps. One is being from the farmer side of the house, the producer. So there are a number of people that are saying, hey, look, I want to be able to transform my operation from chemical type of operation to an operation focused on using soil biology and soil health and that type of thing. And so that's the farmer grower saying, how can I actually transform my operation? And then we have the folks that are going to, and here's an example, like a Corey Miller from Grass Valley Farms, very successful farmer, understood the role of soil health and soil biology, and he's applied it extraordinarily successful to his ranch and to his farm. And most farmers that are able to make that transition very successfully, there's a lot of huge benefits to them. One, profitability. That's always going to be a key thing with farmers because farmers are always in such a low margin or low profit kind of environment. But then also just quality of life and all those other things that come associated with not having to spray these really deadly chemicals and knowing that you're degrading your ecosystems, where now you're actually regenerating ecosystems and bringing life back into the farm and things like that. There's always this really kind of cool aspect to a lot of farmers that when they realize that they're really making that change and seeing those changes for themselves on their farm, it's kind of magical. They're like, wow, okay, I can really feel like this is working for them. So that's the farmer kind of track. The other is saying, hey, I want to be able to do some kind of work, like become a consultant. And I get this question actually quite a bit from people who are thinking about actually taking the courses or signing up and doing this kind of work. And I usually kind of give them the advice that in the consultancy realm, as far as I'm not a producer or grower, but I'm going to be able to try to do this work, there's probably 4 key areas that you can focus that work into. And you can do one or all or anywhere in between. And first, foremost would be something like consultancy, where you have knowledge that your client is looking for you to be able to provide that knowledge, and that's going to be into, how do they make that transition from their current operation, their current management practices into something that's going to be focused on soil biology. And I always look at this as a partnership with my farmers. I'm not an almond grower. I'm not a vineyard manager or a winemaker. I'm not somebody who is growing thousands of acres of tomatoes. And those farmers already have a lot of instilled knowledge about what it takes to run an operation like that. What I bring to the table is the knowledge of how to transform your soils into focused on soil health and soil biology. And it's the partnership between what they know and what I know that is able to then drive that change in their management practices that allows for them to be able to make that transition. And so that's what a consultant really does, is kind of reviewing what they have, making suggestions and changes, running trials, on their land, so you can learn at a small scale. Especially the farmer needs to learn at a small scale what the changes are going to be like, so that they can then ramp them up to a large scale kind of operation. So that's the kind of consultancy realm of it. The next thing is to actually become a compost producer. One of the major challenges that we have in this realm is the access to high quality inoculum. This is, being able to get that, Adam was talking about his compost pile, how you're really trying to be very specific about the type of compost that you're creating. So getting access to that is sometimes very challenging. And so we need more people to become compost producers to create that high quality inoculum. So that's one route that a number of people have taken and said, hey, look, I'm going to become a compost producer. Another space that's a possibility is somebody who does the remediation work, those biological amendments that's making compost extracts, compost teas, being able to spread compost out on large scale operations and things like that. And so these are people who are going to be more around the remediation service. So that's going to be creating extracts, creating teas, having spray rigs or deep root zone injectors, or there's a lot of work that you potentially could do in that space of doing remediation. And then the last thing I would say is going to be a lab tech, somebody who's going to be able to take the samples of either compost or soil or liquid amendments and be able to assess the microbial content and quality of those samples. And like I said, you could focus on one of those. There are a number of people that say, I just want to do the lab work. The microscope, fine. I want to do my lab business. There's others that say, you know what? I don't really like the microscope. I just want to do consultancy work. Or, hey, I'm more of I want to be out in the field doing remediation kind of work. Or I want to do a compost producer. Or you could do all 4. When I started my business, I chose 3 of the 4. I decided not to become a compost producer, but to become a consultant, a remediator, and a lab tech, right? Have my own lab business. I've now removed the remediation out of the equation because when I'm dealing with a lot of large scale farmers, they already have all the equipment. I'm more helping them modify and change their equipment to be able to match the things that we want them to do. But I was successful being a remediator for many years before I decided to remove that from my business. And there's nothing saying that you can't just evolve that over time. So when you're thinking about this, just recognize there's a lot of different opportunity spaces that you can kind of fit yourself inside of. For me, again, it was to become that consultancy role. That's primarily what I do. I still do a lot of lab work, but I consider myself to be primarily a consultant in that space. My colleagues, Keisha and Casey, they're large-scale compost producers. They have catalyst bioamendments, and they've helped set up many other composting operations throughout the United States. And that's really needed work. In fact, our Soil Matters business will do some consulting in that space where we have a number of compost producers that are saying, you know what, I think there's a good market for this. Can you help me transform my compost production into something that's now going to fulfill that kind of need from the biological space? And then Andy, to be a certified lab tech, so this is somebody who's saying, hey, look, I just want to be able to see samples coming in, and I want to be able to create those reports and do that microscopy kind of work. So like I said, a lot of different spaces that you can kind of put yourself into. All right, anything else you want to add here, Adam?
I think the only thing I would add, Brian, is I just want to brag to the people in the room about what you have figured out time and time again works, which is you've gone into several large scale agricultural production systems and said, here are the deficits, or here are the places where this is causing degradation of the soil. Here are some effective strategies that we can employ to get the soil to come back to life. And it's sometimes things like planting annual covers and crimp and rolling those plants over and spraying with a fungal dominant extract so that they start to accumulate that organic matter more effectively into the soil. And you're one of the people that we like to point to and say, there's no scale issue here. This can be scaled. This can work. Adam York is another one who we've highlighted on our YouTube channel. I think he said over 100,000 acres of land that they're managing in southern Illinois with large scale pivot irrigators and things that he used to do all the chemicals, and now he is pulled back on that so that he can invest that money in the biological and ecological solutions instead, saving tons of money every year, right?
Right. Yeah, and that's the thing is it's the scaling question always comes up, and I get this a lot of times from agronomists and so forth. Oh, there's no way you could scale those kind of operations, and that's just absolutely not true. You can. You have to change management practices in order to be able to make that scaling work. And I go through this exercise with a lot of my clients, and this is something I had to learn over time. But really, when we kind of do a review of what do they do on the farm, what are the management practices that you have, and I like to be able to categorize management practices into 1 of 3 categories. One is that management practices is either going to be beneficial and supports good soil health and soil biology. It's going to be neutral, which means the management practice probably has no major effect one way or the other to those to the soil or to the soil biology that's there, or the management practices is harmful. It is going to provide some amount of destruction to soil health and soil biology. And when we have that discussion, it's very easy for us to then prioritize and say, hey, look, everything that we put into that negative category, the category of it's destructive, that's where we need to find the alternative. That's where we need to focus our time in. And if we can knock all those out of the equation, then we should focus on the neutrals and see what we can do to push those into more of the beneficial category. And that's just a good way to help your clients kind of recognize prioritization of what they need to work through. And I have clients today that have management practices that are destructive, but there's no good alternative in what they're doing, at least in their mindset. So we recognize that that's a management practice that's going to be destructive, and we just reset expectations and say, knowing, hey, we can still push the system, but we're always going to be kind of knocking the system backwards with this management practice. And eventually what really happens is the client starts thinking about, it becomes an annoying thing to them, where like, I need to find a way to get around that management practice because I know I can see the transition happening, but I want it to happen faster, right? So there are creative ways that you go about and kind of help your clients through that process. Okay. Anything else, Adam? I think we're probably good in this. All right. So what we're going to do is we're going to have a quick a promo video on a quick video on our June offer, and then we're going to move right into Q&A. And I see that there's some questions that are already coming into the Q&A section. So if you can, please go ahead and put whatever you want to have answered by us in the Q&A section, and we'll try to get to it. All right. So please enjoy our little video here.
Some of the farmers working with soil food web consultants around the world are seeing remarkable results.
Just within the first 3 years of working with these folks, they saved over $1 million just by cutting back on synthetic fertilizers, going from 200 units of nitrogen per acre down to 150 to even 50 units of nitrogen with the same, if not a better yield, which is really exciting.
If we look at the fertilizer savings across 1 hectare, we're looking at about $1,000 in savings. And then when we look at the increased revenue from the yield increases, we're looking at about $504. So the gross margin was increased by about $1,500. And then if you extrapolate this over 200 hectares, we're looking at about $300,000 over the course of any given year.
You can see the average again, 72%. And if you just take a few of those examples, you can take celery or you can take kale, you can see that we reached over 100% of yield increase.
Basically, the weight gain again was like 25% or more. The only complaint they got was the client wasn't used to obviously baling as often because the crop is growing so much better and so much healthier. They went from 280 to well over 400 sacks an acre. So that's 42% increase, which is really impressive. I mean, dollars and cents wise, that's a big jump. The peas were really amazing. They were really aggressive with some of the pea projects. 136% increase, that's pretty impressive.
If you're interested in joining the soil revolution, now is a great time. We are making the Consultant Kickstarter bundle available through June 26th at the price of $39.50 to a limited number of students. With the Consultant Kickstarter bundle, you can register for the Soil Food Web Foundation courses with Dr. Elaine Ingham for just $39.50, saving over $1,000. You'll also get Stage 1 of the Consultant Training Program totally free, saving a further $2,000. That's 26 hours of mentor time dedicated to helping you make your own biological compost and develop your microscopy skills to the standard required to qualify as a certified Soil Food Web Lab technician. You'll also get 2 free bonuses with this offer: the Introduction to Permaculture by Graham Bell and the Soil Sponge Workshop with Dee Dee Purshouse, saving a further $599. The total value of this bundle is $7,599, for which you'll only pay $39.50, saving over $3,600. That's 48% off. Remember, there are limited places available, so please don't delay. Finance options are now available, so you can pay at your own pace with a firm. Kickstart your new career today with Dr. Elaine and her team.
Sorry there, folks. There we go. So yeah, thank you for watching our video about our June offer, and hopefully, I think the offer ends today. So I think today is the last day for that. All right, let's go ahead and jump right into our Q&A here. So first question is from, I'm sorry if I'm going to butcher your name here, but Yelva, I think that's maybe the way to pronounce it. Apologize again if I mispronounce it, but the question is, I'd like to know what you say about why some people that question the importance of the F to B ratio in succession. So I think the question is really around, what is the importance and why do we focus in on F to B ratios? And for those of you that may not know, F to B is fungal to bacterial biomass. So we're talking about the amount of fungal biomass to bacterial biomass. Adam, you want to jump in, or do you want me to take this one to start with?
Yeah, I think that I see very commonly when people are first starting off in this space, like checking out what's on YouTube, reading books on regenerative agriculture, they come across this fungal bacterial ratio concept. And it becomes very much like some kind of like a magic potion in their minds at first. And really focused on like, okay, if carrots are like a 1.3 fungi to every bacteria, then what about parsnips? They're only 1.1 and all. And none of that comes into my head. I look at the general trends. So in general, when we talk about succession in an ecosystem, there are changes in a plant community that happen connected to changes in a microbial community. And when we have soils that are highly disturbed, where we could call them stage 0 or 1 of succession, right? I'm almost imagining that you're starting with new, fresh dirt, just minerals. The thing that's going to first thrive in that system is going to be very specific types of bacteria. And they're going to facilitate very specific plants, which we humans typically call weeds, right? Things that reproduce quickly and spread a lot of small seeds, right? Things that love that disturbance that happens there. And I've even seen this in tallgrass prairie systems where large bison will come along and wallow around. And then the plants that grow where that disturbance happened are like these weedy species, right? They're sometimes in ecology called rudial. They're fast reacting species. And they're primarily focused on bacterial partners, right? But in those systems, not only do you have relatively more bacteria in the biological community, and you do have some fungi, but they're like yeasts primarily, right? Things that can, again, can spread rapidly, and they're okay with shifting conditions. Typically, there might be a lot of water pooling on the surface of that disturbed area because there's not good infiltration and it goes anaerobic. So you see a lot of species in that microbial community that can shift rapidly their strategies between a low oxygen and a high oxygen environment. So all of that speaks to bacteria on that end. As we go all the way to the opposite side and we get these like stable late successional forests, you might call it stage 6 or 7 even of succession, they tend to be very dominated by fungi and very dominated by aerobic fungi. The fungi themselves have improved the structure of the soil so that deeper and deeper into the profile, you have lots of oxygen, water flow. It's like a nice sponge. What happens in the middle is a gradient. And even if you're in late succession, you have bacteria. And even if you're in early succession, you have fungi. These things are not discrete categories. That's a human way of thinking. We have to define everything and come up with a number for everything. And nature is much squishier than that. That's my technical term for it, squishy. It's not black and white. It's grays. It's a spectrum of things. And there's always habitat for bacteria and for low oxygen loving species, even in late succession. And there's always habitat for some of the aerobic fungal organisms in early succession. But in the middle and along that pathway, the idea would be match the plant to the conditions it developed in, right? It adapted in. So then we go and say, okay, well, here's how corn, for example, maize, grows in its native circumstances. Can we give it something similar in our agricultural systems? But I have a corn farmer down the road from me who tills multiple times a year and pulverizes the soil and leaves it bare to try to knock back all the organisms in there. And really, I'm certain that if I were to go look at that soil, it would just be like a bacterial dominated system. Whereas actually corn in its native circumstances is going to have a lot more fungi, right? It's going to associate with a lot of mycorrhizae and other things. So these patterns, I don't believe that we just like cook it up like some kind of factory cake and we just get these all the time the same way. No, we have to live in relationship with these organisms. But understanding the patterns is very useful and knowing what your target is. Most agriculture is in stage 3-4 of succession. Most of the plants that we depend on for like cotton, like wheat, these things that we grow extensively to create the raw materials that we need in our society, they want a system that's primarily going to be, 1-to-1 or 2-to-1 in fungal to bacterial ratios, maybe even up to 5-to-1 in the case of cotton, because it's really kind of a shrub. And we're giving them systems where there's barely any fungi and barely any protozoa and barely any nematodes. And then those systems are fragile and we have to juice them up with these external inputs and do all this maintenance throughout the whole season to baby our little plants along because they're really not thriving. They're really not thriving. And that's the lesson I've tried to bring in from succession, is to understand that relative story that, later in succession, you're going to have a lot more mutualists and a lot more aerobic fungi than early in succession. And so let's match the soil biological community with what the plant is looking for.
Yeah, and this is something that comes up a lot for me too, which is, when we do the work, the practices where we're going to be putting inoculum out there. So like Adam said, most of the agricultural space isn't even landscaping and even in some of the ecosystem restoration projects we do, the the community, the microbial community is just not set right for the types of plants that are trying to grow in that community through whatever practices or for whatever means that drove it to that space. And so we use something like compost or compost extracts or compost teas. And one of the things that I come across quite a bit is saying, you know what, we're going to apply this to an orchard, let's say. And my orchards, I'm typically trying to achieve a fungal to bacterial biomass ratio of 5:1 to 10:1, somewhere in that range. And that seems to be kind of appropriate for those types of orchard, for the trees that are growing in there. And we may be not even we're close. We might be at 0.1 to 1. It's primarily bacterial, just simply because of the conditions that are in that soil. So what will happen is we're going to apply a compost or compost extracts or something similar to that. And the compost that we're using may only be like 0.7 to 1 or 0.8 to 1. And people will be concerned and say, well, we need a 5:1 or 10:1. Why are we putting on mostly, highly bacterial with some fungi versus, all, highly fungal types of sources? Because that's the quality of the compost that we have. But I will say this, if I put compost out there, let's say it's 0.7 to 1, still, mostly bacterial, but still has, fungal component to it. The plants are going to drive that community. Over time, the plant's going to really pick the winners and losers in the microcosm that's there. And you'll see that as long as I'm providing a good diversity of fungal inoculum, that there are spores and a good amount of fungus that, even though it still may be more bacterial, the plant over time will start to adjust that and move that to where they need to be. As long as we're moving out those management practices that are constantly setting back, the microbiology into that soil. So, one thing I try to get people not to get too hung up on is saying, if I'm going to apply this compost or extract or tea, and it's not at the ratio that the plant wants. I don't have a 5:1 or a 10:1 extract, then don't use it. Well, that's not true. Just make sure that the compost or the extract or the tea that you're using has a good diversity of those sources in there. The plant will start to foster those relationships and pick the winners and losers that it wants to see. So don't get too hung up on it. The biggest thing to my mind is change the management practices that keep on setting the microbiology backwards. Provide the inoculum, the plant will then set itself to what it needs to have in that F to B ratio.
I love that you brought that up, Brian. You have such a practical way of talking about this. And I should mention that, when I'm growing tomatoes in my garden, that my overriding goal is I usually start them and transplant them, right? I want those transplants to find a soil environment that facilitates partnership with all these beneficial organisms that are there. If the organisms aren't there, they can't make the partnership. If the conditions are harming the plant or the microorganism, setting them back, they can't reconnect. And that's often what we're talking about, is like the relationships were broken previously, right, and we have to find a way to get them to reestablish and become friends again, right? Become a community again. And we're the stewards of that. So I just try to make sure that soil my plants are going into has here's another technical term for you, a crap ton of fungi and fungal diversity, a bunch of protozoa and protozoan diversity, a lot of beneficial nematodes and nematode diversity. I barely even pay attention to the bacteria because those other organisms are more sensitive. Mm-hmm. And if I've got them, they indicate to me I have all the context to pull this thing along and to give the plant the partners it needs, and they will figure it out. They're smarter than me.
Yeah. Okay, let's move on to another question here. So this question is from Ryan, and the question is, about career opportunities after certification, specifically after end of course testing. I understand we need to market ourselves or start a business, especially in the areas with little regenerative farming. Are there laws that prohibit soil samples from crossing state lines? I'm in Texas and there is more lab tech work closer to the West Coast. My main concern is the timeline for finding work if I don't want to start another business immediately. As a multi-business owner, my current ventures are very time consuming. What's the general timeline others have found work after lab tech certification or as a biocompost producer? I'm considering the web consultancy, but hesitating if it's a year-long process before I can switch from my current business to anything in the soil. Okay, so there's a number of things I think to unpack in here. Do you mind if I take a crack at this first, Adam? All right, so the first thing I'd have to say is around marketing your business, because that's always going to be a thing. You are going to get all this knowledge, this education. Now you need to be able to connect yourself with potential clients that are out there. And marketing is one of those things that you have to do as a business to try to say, hey, look, I'm out here. Here's I can help you with the problem that you have. I'm not a natural marketer. I don't go out and put together a lot of marketing campaigns and try to push myself in that sense. For me, the way to market was more about sharing knowledge and education. And so when I started my consultancy business, what I did was I found the local growing groups. What were, the vineyard growing group, the orchard growing group, there's a tremendous amount of different groups of people like master gardeners and so forth that meet and talk about the growing of plants or the conservation of ecosystems and things like that. And what I did is I just said, hey, look, I have this knowledge. And what I'd like to do is be able to share that knowledge. Can I give you a 15-minute, 30-minute, an hour-long presentation on life in the soil? And these were the things that I had learned both from the school and from some, the education sources I was pulling from around me. And that was my initial way of getting clients, because I would talk to these groups. It naturally would they'd have questions and there would be follow-ups. And then there were a number of people that said, hey, you know what, let's go and do a trial. I want to be able to try these practices on my property and go in that route. And then from there, really a lot of things became word of mouth, one farmer talking to another farmer. And that drove a lot more of my business. So could I be more successful or have more clients if I was really putting on some very focused marketing campaigns? Probably, but that's not kind of my skill set or where I naturally see myself. So that being said, I think there are many ways that you can try to market yourself without actually being a marketer. And I also look at this too, that the opportunity space here is huge. The amount of us that can do this work is very, very small at the moment, right? Now, there are significant headwinds in front of us. There's regulatory concerns. There's financial considerations. I know one of the things that I run into a problem with sometimes now is there are farm loans that if farmer's going to take out an ag loan, the bank is saying you have to apply these products. You have to do these management practices or we won't give you a loan. And that is massively problematic for us. Now, I have to say with some optimism that there are some some banks that are looking to, or that are creating more of these regenerative agricultural farm loans, or that are in the opposite sense saying, you can't spray these things, you can't do these things, you have to do these things in order to get that loan. So there is, I think, a change in that marketplace that are happening. Another thing I talk about here about state lines. So I do have clients that are across the United States and some international clients. As far as shipping lab materials or samples and that type of thing, in the continental United States, that doesn't seem to be a problem. If you're going to try to ship things to Hawaii or from Hawaii to here, yes, that is a problem. There are very special regulations that you have to follow. You have to have something like an autoclave, which you can see right behind me. I'll get my finger pointed right there, to help sterilize the samples and so forth. So there are some procedures and practices that you have to follow to be able to do that kind of work. So the other thing, Ryan, the only thing I could really say is that, yeah, when I started my business, I was still working full time in my corporation, high tech job that I had, and I did the business for 2 years before I actually made that transition full time into doing the soil biology work that I do today. And so you have to find for yourself what is the right time to be able to move. And for me, it was having the right base of clients and knowing that I had the knowledge and the confidence to be able to go out there and tackle larger scale, clients and so forth. So, Adam, do you want to add anything to this?
Because they mentioned the geographic boundary issue, and that can be different from regulation versus, what I would look at technically. I did post in the chat the One Earth's bioregion map, because I think that to the greatest possible extent, we should just have the ethos of be as local as possible. So when you're collecting materials locally, making compost and then selling it locally, even within a smaller area than a state, there is an advantage that you're getting populations of organisms that are adapted for those local conditions. Now have plenty of parts of the world that are changing their conditions, especially in terms of their weather and climate patterns. However, you're still going to find the most resilient adaptation capacity and genetics and capacity to partner with local plants, which we should also use to the greatest possible extent. Within that, let's say 100 miles of where you are. That's just going to be a decent rule of thumb. And then I see in the chat that people have said, there's different regulations with compost around the world, and there's so much complexity there that we don't really teach composting regulations. We are constantly pointing at the USDA organic, requirements, because if people want to work, especially in a consulting space, they should understand those are some of the most strict. The issue with them, and Elaine has talked about this publicly several times, is that they're overly focused on heat as the mechanism to control pathogens, right? And so it's this very sterilize it mentality. And we actually find that the biological competition of having that thriving community of mutualistic or neutral organisms is just as important as heat. And even compost, which didn't meet our time and turning and temperature guidelines here, could become food for worms or other things that over time you'll see that community shift and all the pathogens are still suppressed, right? And then it would be okay to use. But your local regulations and the agencies and country and even county or state or province level regulations, you definitely have to understand those if your goal is to sell compost. We're teaching principles and practice more than anything here at the school.
Yeah, it's a good point. And I was mentioning, when I kind of describe those 4 areas of work, when you're doing remediation work and you're making compost and that type of thing, it tends to be very localized to the environment that you're at. When you're doing consulting work in lab tech, you can, be much broader and be able to provide advice and then be able to take samples in. But it also helps you too that if one of your clients wants to become a compost producer in another state that you're not familiar with, make sure that you're informing them to be able to look at those regulations to understand what they are, because they can differ from locality to locality. So. All right, Adam, I think let's take one more question. I know we're a little bit past, but let's do one more. All right. So this one's from Amanda and somewhat similar. Do you need to have lab tech skills, though, to be a consultant? Otherwise, how will you know what the client is missing? And that is a great question. There are some of my colleagues that have learned on the microscope and they're consultants, but you know what? That's not something that they want to do long term. And there are plenty of labs that are out there that will do this microbial analysis. And what you need to know as a consultant is the ability to interpret those results and understand what they are. Personally, for myself, I like to have my microscopy and my consulting businesses together, because I like to be able to see and look at those samples with my own eyes and make my own determinations. But it's not required. But I would say it is one of those things that many of us actually really, really prefer to do. It's to look at the samples that I'm going to be advising or giving my advice upon versus just looking at a report. Now, that's not to say that I don't have clients that already have a lab tech and they are just sending me the the results from the microbial analysis, plus the chemistry analysis, the leaf tissue analysis, the plant sap analysis, all these other data points that I have to try to consume. So it is definitely possible to be a consultant without maintaining the lab tech, where that's part of your core business. Now, I have to say this though, to become a consultant, you will go through all the lab courses to make sure that you understand how to do microbial analysis and what that really takes. So no matter what, you're going to gain those skills. The question is, does it become a core part of your business? That's up to you, really. Adam, anything you want to add to this?
The only thing I would add, it kind of goes back to the F to B ratio discussion as well, which is over time with experience, it's better to focus on the trends and patterns than the numbers. And I see a lot of people like stressing out about, oh, is it 135 or is it 150 micrograms per gram, blah, 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 blah. And again, I said, I want to see a bunch of diverse fungi. I want to see a bunch of diverse protozoa. I want to see a bunch of diverse nematodes. If I'm looking at my compost pile and I just see like a few round bacteria, there's something is not right. That's not really going to help to apply. I'm putting some nutrients and organic matter in, but I'm not bringing in that diversity of life that I want to see. And so there's a way in which you go through the microscopy training, and we teach you as if it's to set up like this laboratory assessment. And if you go the lab tech route, you're wanting to be very consistent in your own internal process and in comparison to other soil food web labs. I know many consultants, gardeners, farmers, people who take our courses, and they say, I can kind of get into this shorthand thing where I just look and I get this broad overview of what's going on. And so often there, the story is really obvious. This is dirt with a few bacteria. This is soil with a thriving soil food web. And that's the difference that they see. And when they start with dirt and they go find compost that's bursting with life, or they make it, sorry, and it takes time and practice, and then they start applying it, they see their dirt turn into soil. And that's the brilliant thing with microscopy at the end of the day. It's not just about laboratory reports and numbers and sifting through all that data. It is about seeing with your own eyes something that you can't see without the microscope, which is lifeless becoming full of life.
Yeah. And there was something that you really keyed on to, that it's a key thing as a consultant type of thing, is the trend analysis aspect of this, which is if you just take one microbial assessment, yeah, you got a point in time what you're looking at, but it's not telling you how that system is moving in one direction or the other. And so by taking microbial analysis over a period of time, and usually when we're doing this kind of work, we're trying to make sure that we're pulling samples from the same locations, same time frames year over year, same, the life cycle of the plant. We're going to say we're going to take it when, the flowers come out, when the fruit gets set, when, and so forth, so that we're able to go through that process and trend it over time. That's really, really important for us to do. And the other thing that you mentioned too is about some people, want to be more about what we call the quantitative analysis, which means we're going to extrapolate and really give us some numbers about what we're seeing. Then there's the qualitative analysis, which is just, I'm going to look at and see what I see. Does it look like it has a good amount of fungi and protozoa and nematodes? I have a lot of my clients that actually, all they want to do is just do a very quick qualitative analysis and just see how things are looking. And then all of a sudden, when they themselves see something going wrong or something very different, it's like, whoa, Brian, I got a sample I'm sending to you. I want you to take a look at it. Tell me what you see, the type of thing. And they're able to catch things earlier because they're doing that kind of qualitative analysis. And the last thing I think I'd like to mention on around data in its own right, microbial analysis is typically just one of the data points that we look at. We will usually pull in soil chemistry analysis, plant sap analysis, tissue analysis, water infiltration analysis, compaction analysis. I mean, there's a lot of other data points that kind of come into this whole spectrum that we are then going to assess. And what we're really trying to do is in some way give a score or give a health check to say, yes, it looks like the microbes are increasing the way we want them to increase. We're seeing better results in plant sap or tissue analysis. The soil chemistry, we're seeing less of these toxic kind of, quantities of certain elements in the soil. And it's all of that data that really helps us determine what that health is going to be. So anything else, Adam, you want to add?
No, I love it, Brian. I typed while you were talking. It's like you're triangulating the evidence. You're looking at the plant, at the soil, at the microbial population. They should all be pointing in the same direction, which is towards systematic health. It's sort of like going to the doctor and getting some blood work done.
Yeah.
To say, are you hitting the numbers all over these different places? Love
Exactly. Okay, I know we ran a little bit past, but thank you all for the questions, and I'd like to give a big thank you out to our team of people that put these webinars together. It's a lot of work. There are 4 webinars in this webinar series, and in about 3 months, we'll have another webinar series that we'll do. So it's a lot of behind the scenes work, and we really appreciate the entire team that puts all this together. And then I also like to thank you as the audience. Without you attending, there would be no reason to do these things. So we really appreciate the energy that everybody comes into these webinars with of trying to improve themselves or get more knowledge. So that's wonderful. And Adam, thank you so much for today, for being able to share your knowledge.
Thank you, Brian. I always appreciate the chance to interact with somebody that's doing it in the field, doing the thing.
Doing the thing, exactly. All right, with that, we're going to go ahead and end it. It's a wrap for this webinar series, folks. And if you want,
Cheers.
remember, there's the other 3 that are out there. You can always look at the replay. So,
Cheers,
all
everyone.
right. Thanks all. Bye.